Hi everyone, welcome back. In this video, we're going to test the Rogers Sound Lab IA255.1 Ultra Compact Integrated Amplifier. So I purchased this from RSL and it's $110 US, so it's in the extremely affordable category, especially considering its feature-rich content. So you can see here has bass, treble, volume knob, has 3 different inputs: USB, Bluetooth, and line level input. On the back you have a high pass filter switch to filter out bass from the pre-out, and then you also it also does the same for the speaker out, and it has pre-out to act as a preamp. It can also act as a DAC with volume with pre-out. And so there's just a huge flexibility here and being able to do whatever you'd like to do with it. It has 55 watts output and a 4 ohm load. And so in this video, I'm going to do some distortion measurements, compare it against my reference amplifier, which is the Hypex FA123, and then my listening impressions on this in comparison to a much more premium and costlier product, which is the Hypex. So this is kind of my first foray into testing electronics. I've revamped my test bench to be able to do distortion measurements with noise floor down into around 130 dB of dynamic range. And so if you have any questions about my test setup, just shoot me an email and I'd be more than happy to let you know how I have that set up and what equipment I'm using. Okay, so why the Rogers? So the Rogers kind of is a mid-ground performer that I wanted to kind of feature. I want to continue to feature more electronics in my testing, because as I continue to test loudspeakers, drivers, woofers, tweeters, compression drivers, I'm finding more and more that the upstream electronics are having kind of a bottleneck effect on the overall distortion / sound quality. And so it becomes important to look at how these electronics are performing, especially in the context of high sensitivity loudspeakers, and even more so with compression drivers, where the amplifier is typically only outputting like one watt or less. And so kind of contextualizing this and looking at the sound quality when the amplifier is outputting extremely low power levels for when you are using high sensitivity speakers, and even more so looking at the sound quality for the upper treble. Now, I know a lot of distortion measurements that are published simply only look at the mid-range region. However, it's even more sensitive and to look at how the performance is when you're looking at the upper treble. And so amplifiers seem to fall short in that regard. And so that's why we want to scrutinize this aspect. Upper treble is so important for, the overall musical enjoyment. And so we want to focus in on that. So going back to the product, the Rogers unit uses an Infineon chip, which is out of Germany, and so we're going to be looking a little bit at that. So we do see the published distortion measurements from the chip manufacturer. You can see here that depending on the configuration of the chip, it can have distortion around 0.01 at the 1 watt output. And so that's kind of generally where we do find the distortion on this unit. Beginning with my own, I do a multi-tone, multi-band test signal for intermodulation distortion, which you can see here. So this is the actual distortion at a very low output voltage of only 0.13 volt. And so this represents, I believe, around 1/8 of a watt, which is actually quite common when you're listening to high sensitivity speakers, 98, 99 dB sensitivity. You're really only outputting around 1/8 of a volt, which is quite, it's in the milliwatt territory. So we see here, this is the distortion. We get a slight rise in IMD as we move into the upper treble. And so dynamic range is around 65 dB for this use case scenario. Now, if we want to increase output voltage to 1 volt, You can see here that we do see improved dynamic range at minus 73 dB, and this is about 1/8 of a watt output. Increasing it to the 2 volt, which is half a watt, we do see a slight degradation in dynamic range at minus 68 dB. And so this is actually quite good performance, especially comparing against what was available 10, 20, 30 years ago. This is excellent performance, and considering the cost, this is even more excellent. So now I decided to do the exact same test with the Hypex FA123. Now this uses an R-Core. Is it R-Core? I believe that's what they call it. It's a special Class D technology that's used by Hypex, and so you can see here for the same 2 volt output, you can we have 84 dB of dynamic range. You can see there, so significant improvement in distortion. However, it's not really a fair apples to apples comparison considering the cost of the Hypex, which is probably 7 times the cost at around $700 US for this DSP plate amp 3-channel. Okay, now I'm going to just quickly show you the Gedley metric as a function of frequency. So the red line is the Rogers units distortion performance, and then the green line is the Hypex. And so you can see the Hypex actually gets extremely low in terms of the Gedley metric. So as you go from bass, mid-range, treble, you can see that the upper treble, the Hypex is, you got to count the zeros here. It's 0, 0, 0, 1 as a scale of 0 to 10. So the Gedley metric is simply a sound quality factor that's from 0 to 10, with 10 being higher distortion. And so you can see here with the overlay between the Rogers and the Hypex, the Rogers isn't nearly as good as the Hypex. Now, I should mention too that the Hypex is a world-class, one of the lowest distortion amplifiers, but we at least can see that for comparison's sake. Looking at harmonic distortion, I tested it at the 2 volt output. You can see here that distortion does remain low until we get into the upper treble. So we're at 48 dB dynamic range for third harmonic, and then 51 dB for the fourth harmonic there for the Rogers unit. Again, if we compare it against the Hypex, the distortion is so low on the Hypex that it's below our vertical scale. So we have to increase our vertical scale within the Artist software from 100 dB up to 140 dB so that we can reveal where those distortion artifacts lie. And so it's a full 83 dB down at 10 kilohertz for the Hypex. So again, just confirming that both my test setup is able to measure that low, that we're not just simply seeing the noise floor of my test setup for the Rogers, but it is able to measure much lower than what we're seeing with the Rogers performance. So so I decided to test the DAC's performance. So it's a USB DAC with pre-out, and so I measured the pre-out's distortion, and the best case was with the volume knob at about halfway, and I was getting about 60 dB of dynamic range. So not an excellent performer, but kind of middle of the road average performer in this use case. So I set it up and had a listen, and I directly compared it against the Hypex as well, just to kind of see if the differences were in fact audible. Now, I would rank the smoothness at 8 out of 10, which is actually quite good, simply because it did have kind of a smooth, relaxed sound character. I noticed that compared to the Hypex, it did lack a sense of dynamic range, and then the soundstage depth was noticeably less than the Hypex, and so I gave that 7 out of 10. So there is a noticeable kind of audible difference between the Hypex and this Rogers unit. So I would say that the Rogers unit is suitable for background music, television listening, and for gaming. Its overall sound character is pleasing, and it has a very relaxed sound character. It's competent for non-critical listening applications. So the unit can serve as a USB DAC / preamp, like I mentioned, but unfortunately, even in this use case, I would not say that it's suitable for like a critical home hi-fi setup. So overall, it's feature packed. It's very nicely built. Has an aluminum case. It's not kind of a cheap steel situation. So it's a very competitive product for its price category. Unfortunately, I didn't find it suitable for critical home hi-fi listening, but otherwise it's a very flexible unit that can be used around the house. So there you have it, the Rogers SoundLabs IA255.1. Take care and have a great day.